Alright, so now we need to finish just one more, the last part of this question here. So we need to state the restrictions. And to do that, we're going to look at this simplified, or I guess, yeah, simplified log. And what I'm going to do is I'm going to convert this into exponential form. It'll kind of help us see what we have to do with y and why we'll do it. So here we'll have 6x is equal to y to the 25 over 3. Now we don't need to do a variable, or we don't need to set any restrictions on x, but we do need to set some on y. And why do you think we have to do that? So looking at y, no matter what value you put in for y, or for x, sorry, are you ever going to get a 0 value for y? Will any exponent give, will it make 6 0? And that's no. So y cannot be 0. You can ask yourself, can y be greater than 1? So can it be either a fraction? Can it be 1? Can it be, 2 or 6 or something? Can it be just a positive number? And that is yes. So y can be greater than 0. Because remember, if we had a negative exponent, that would give us fractions. 0 would give us 1, and then any number bigger than that would give us any number greater than 6. Alright? So, then our other possibility is what happens when y is less than 0? Is this possible? So, kind of along the lines of what I was just talking about, there is no possible case where 6 times any number many times of 6, it will never give you negative. It could be possible if we had negative 6, but 6 times 6 times 6 times 6, or however many times you want to do that, no matter what exponent you raise 6 to, you will never get a negative, value for y. So that means that our only possibility is that y has to be greater than 0. No exponent will ever give us 0 or a negative number. So our restriction here is that, and we'll just write this up here. So our restriction here is that y must be greater than 0, where y is an element of all real numbers. Alright, so it's a lot easier. So put this into exponential function, or into exponent form, and then from there ask yourself, well, can it be in this range of numbers? Can it be here? Can it be there? So you got the basic 3. Can it be a positive number? Can it be 0? Or can it be a negative number? Those are your basic 3 scenarios that you guys can have. And so ask yourself, when would that happen? And of course we see here that the only logical solution is that y must be greater than 0. Okay? So I'm going to erase this, and we're going to move on to B. So for B here, we have the log of x minus 3 plus the log of x plus 4. If you guys remember this one, so just remember, when we don't have a base, that just means that B is equal to 10. We don't really need to know that for this one, or at least until not just yet. So now we're going to rewrite this function here, or expression, using our log laws. And if you guys notice here, we have that plus sign here. So that means that we're going to be using that product rule. So we're going to rewrite this as the log of x minus 3 times x plus 4. So what we can do from here is we can expand, we can distribute. If you guys remember, you guys can use FOIL. So you'll rewrite this as x squared, that's your first, we'll do the outside, plus 4x, inside is negative 3x, and last is negative 12. Then we can simplify and collect some like terms there. So you have the log of x squared plus x minus 12. So that's fully simplified there, and we rewrote it using those rules. And so now we just need to talk about the restrictions. And this one it's a little bit more tricky. It's not as easy as, or it's not a little bit as straightforward as our first one was. So what we're going to look at is we're going to look at these factors here. So here we have, we don't want to start off, we don't want the log of 0. We talked about that, so we don't want the log of 0 because there is no way that we can raise 10 to some exponent that will give us 0. That is not possible. So first of all, we can already say that x cannot be equal to 3. So that'd be setting each factor equal to 0. So x minus 3, move the 3 to the other side, we get x cannot equal to 3. And then our other one we can get is that x cannot be equal to negative 4. So from here, now we need to ask ourselves, so we found out when we would have 0 as, I guess, as in our log function there. So now we need to ask ourselves, well, when would we have a negative number? And so there's two important things here. So we have to look at this whole thing as just one term, because if either one of these end up being negative, then the whole term is going to be negative. So we need to look at what term can we start with, or should we be greater than or less than, that would give us a positive term for this whole thing. So that means that this value in here cannot be negative, and this term in here cannot be negative. So what we can do is start off with, well, x has to be, in order for this one to be positive, x must be greater than, and we don't want 0, so it must be greater than 3. So that's why it's not also equal to. It can't be equal to 3, but it can be 3.1, because then we have 0.1, which that's possible. Looking at the second term here, we have x, and what value would give you would make the second factor here greater than 0, and that would be when x is greater than negative 4. Okay? So from here, we have to look at which one here will give us, or which one here would make sense to, if we just set this as one restriction. So I would say we can't use x greater than 4, because this is in general, so it's looking at both of these. So if I put in x is equal to negative 4 in the first factor, that's going to give us negative 7 there. So we can exclude this one. So you have to go which one will always give you a positive value for both factors. So exclude that smaller one and go with the bigger one. So here we're going to say that x must be greater than 3. So it kind of meets all these restrictions. So here, x is going to be a positive number, and it's not x is greater than or equal to, so that in itself will help to cancel out, or we don't include these other restrictions that we have here. So if we say that x has to be greater than 3, it will meet all of those little criteria. So it's going to be positive, it's not going to be equal to a negative number or 0. So that's kind of what you're looking for when you guys complete your restrictions, okay? So that's your restrictions for B. Alright, so moving on here. The restrictions are a little bit tricky, but the more you work with them, the easier it'll get. So just remember, so ask yourself, when will it be positive, when will it be 0, when will it be negative, and you want to exclude those factors for when it's going to be negative or 0, okay? Right, for example 3 here, we're going to be evaluating each expression. And so for our first one here, we have the log of 4, 8, plus the log of 4, 32. So what we're going to do here is we're going to simplify using our laws. And to start off, if you guys hopefully starting to recognize these laws, we have a plus sign here, so we're adding. So that means that we're going to be using that product rule. So we can rewrite this as the log of 4, and you take m, which is 8 here, and n, which is 32, and you're going to multiply those two. Then from there we'll simplify we'll multiply 8 and 32. So we'll have log of base 4, and 8 times 32, if you guys either punch on your calculators, you guys can, if you guys know that, or do the math in your head, we have 256. And now that we have this nice simplified logarithmic function, let's change this into exponential form. So back, we've already looked at evaluating expressions, and typically we do that using exponential form. So we're going to convert this into exponential form there. So we're going to write this as, and if you guys remember your Ben the log bunny, this is b, your base, your number, n, and your exponent here, which we don't have it labeled there, but we'll just give that a variable. So that way we can write it as that. So then we're going to write it as Ben. So here we had bunny, now we want to write it as Ben. So here we have the base 4, your exponent, which we didn't know, but we can give that one, say, x, and that is equal to n, which is 256. Then from there, what we can do is we can rewrite 256 as a base of 4, and that's of course as long as we can write it as a base of 4. And this situation is kind of nice, we absolutely can, so let's rewrite. So we have 4 to the power of x is equal to, that is equal to 4 to the power of 4. Now that we have the same base, using our rules that we know about exponents, we can set our exponents equal to one another, so we have x is equal to 4. Okay? So now for our next one here, we have the log of base 6 and 216, and that is the 4th root of 36 there. So this one's actually, we're not even really going to be using our laws here because it's already been simplified into one expression, but one thing that we do need to do is we need to clean this here up. That looks pretty messy, and what we're going to do is we're going to rewrite them as, first of all, we're going to change this radical to be an exponent, and then we're going to rewrite them, if we can, as the same base. That way we can simplify it to be a really nice term. Alright, so we're going to rewrite that as the log of base 6, and for now I just want to deal with just that radical there, so we'll rewrite that as 36 to the 1 over 4. So remember that index becomes that denominator of the fraction. Then if we can, let's rewrite these as the same base. So starting off here, I can see that 36, I know that is equal to 6 squared. So let's see can we rewrite 216 as a base of 6? And if you guys play around with that, actually you would notice that. So we have the log of base 6. So 216, we can rewrite that as 6 to the power of 3. So you probably, if you were playing around with it, probably wouldn't have been very much, since we know 6 squared, so then you probably maybe would have went with what is 6 cubed, and you would have found that it was 216. Then from there, let's rewrite. We have 6 squared to the 1/4. And then let's clean this up here. So that is equal to the log of base 6. And if you guys want to do this in one step, that's absolutely fine, or maybe we'll do this in 2 steps here. So we have 6 to the power of 3 times that by 6, and using our exponent rules, we have an exponent to an exponent, so that is multiplying there. So we have 2 over 4, which is just 1/2. And cleaning that up some more, we have the log of base 6, and when we have multiplication, this here we're going to be adding those exponents. We have 6, and if we can just write this off to the side, so we'll do 3. We can rewrite that as 6 over 2 plus 1/2, and that is equal to 7 over 2. So that's our new exponent. So we have 6 to the power of 7 over 2. Then from here we have it really nicely simplified. We have one base and we have an exponent, so let's rewrite this into exponential form. So remember, we have b, n, and e. So we have our base of 6, our exponent, let's say x, and that is equal to our number 6 to the power of 7 over 2. Now we have common bases, so now all that we have to do is set those exponents equal to one another, and we have x is equal to 7 over 2. Alright, so not so bad. We've done this before, I believe in 8.1, so not so bad. Now let's move on to the next video, which we will finish C.